everyone. So today we are going to start um, the feature engineering part. In my previous lecture, I have already explained the basic of NLP. So let me just do a little bit, I can say, not revision, but just what we have done last time. So in my first NLP lecture 1, I have covered the basics. Uh, when I say basic, it means what do you mean by NLP? Okay, what is the okay what is the history of NLP, how NLP was changed from rule based to the machine learning and then deep learning, and then currently we are using the generative AI. In my second NLP lecture, I have covered the some of the one of the important stuff, that is the text pre-processing, because in NLP, uh, language is a data. That language can be a spoken language or written language. So before we are building any model, it is very important to do the some kind of text pre-processing. So that was something that I have completed in the second NLP lecture. Now today we are going to learn in NLP this third series called as the feature engineering. Don't worry if you are listening this word first time, don't worry, I'm going to explain what is the feature engineering, right? So please, again, I'm requesting, before coming to this lecture, at least watch my first and second lecture, so it will help you to do some foundational knowledge, right? Now we will start with the 1 second. So now today we are starting with the outline. So let's first understand what we are going to cover today. As earlier also we have did this. So what we are going to cover today, the first is that what is the feature engineering in NLP and how it is different from the in ML. Okay, so feature engineering in NLP. Second, we are going to learn some of the technique to do this feature engineering. It's called bag of word. It is also called as a BOW. Third is the TF-IDF. Okay, TF-IDF Vectorizer. And then fourth is the engrams. Okay, so these are the stuff we are going to cover today. Fine. Now let's understand with the first topic called as the feature engineering. So what is the feature engineering? See, in earlier lecture, let me start with the flow first. Okay, so initially we have this flow, right? So we have data, then we do some kind of pre-processing, and now we got the pre-processed text. So this is what kind of text? Pre-processed text. Now this pre-processed text our computer will not able to understand, right? Whether computer will understand? No. So we need to convert this pre-processed text in a suitable format. In the format so that the computer, or I can say my machine, is able to understand and do some mathematical operation on it. Okay, do some kind of mathematical operation, or I can say it will do some kind of statistical analysis. Statistical analysis, right? So we need to convert that text representation into such a format so this operation is possible. Now to achieve this, or this process of converting the text into this kind of format, suitable format, generally it's a number or vector, this is called as the feature engineering in NLP. This is called as a feature engineering in NLP. I hope you understood what is the definition of feature engineering. So what are the techniques available in the feature engineering? These are the techniques available. One is a bag of word, second is the TF-IDF, and the third is the uh, engram. Okay, not only engram, but there is also, after engram, there is a one technique which is a state of the art technique called as the word embedding. Okay, this is called as a word embedding. So that these are the technique we are going to learn. Now let's understand the first technique called as a bag of word. In shortcut, it is also called as the BOW, BOW, or bag of word. Now this is a very simple approach to convert your text into the number. While doing this, it ignores the grammar and it ignores the word order. In bag of word, it ignore the word order and the grammar. Don't worry, I'll explain practical also and theoretical also how it is work. So what happened in the bag of word? Some weightage is assigned to the word. Okay, so this weightage assigned to the word. So what is the parameter to add those weightage? It is depending on the frequency. So when I say frequency, how many times that word appears in a document or the document collection, based on that the frequency is assigned. For example, let's say I have three sentences. Okay, I am playing. Okay, second sentence, there is a second sentence, let's say I am studying. Okay, so if these two words, you can see that I and M come two times. Okay, so the frequency of I will be the 2, frequency of L will be the 2, and the frequency of playing and the studying will be the 1. So converting these words based on the frequency is nothing but the bag of word. I hope you understood what do you mean by the bag of word. So I just giving the basic, but soon I'll give the different way. There is a subtypes in the bag of word to achieve this. So I hope you understood how the bag of words work. Now next is the TF-IDF. Second is the yeah, second is the TF-IDF. So what is the full form of TF-IDF? TF stands for the term frequency, and the IDF stands for inverse document frequency. Inverse document frequency, right? So this TF-IDF is built upon the bag of word. Okay, so in the term frequency, it will first calculate how many times that word occurs in a document. Okay, and how many times that word appear across the document. So what happen when you calculate the word across the document? So in the TF-IDF, it is giving more importance to those words who appear the less time. Okay, so the single, if some words appear frequently in a single document but rarely appear in the corpus, then that considered as a most important. So what is the advantage of this TF-IDF? Advantage is to identify keywords. Okay, let me use another pen. Identify keyword that are distinctive to specific document. Okay, that are specific, distinctive to specific document. So those words are very important when we are doing the TF-IDF. The third I can say step, the third most important doing the representation of text into the number or vector is called as the word embedding. So in word embedding, this is the advanced technique. In the advanced technique, you are converting text based on the semantic meaning. So word embedding is very helpful to capture semantic, okay, to capture semantic relationship between words, between words. Okay, so based on the semantic meaning, it will do the relationship. Okay, it will do the translation of text into the numbers. So as of now, we have learned there are the majorly three, okay, three technique we have learned. The first is the bag of word. Second, so bag of word is a very simple technique where you convert the text into the number or in numbers based on the frequency. The second is the TF-IDF, which is a again built upon the bag of word, but the advantage is that you are also calculating the frequency based on the how many times that number appear across the document. Don't worry, I will explain the formula as well so that it will give the more understanding how it is calculated. And the third is the word embedding. As compared to bag of word, TF-IDF, it is not only consider the frequency, but it also consider the semantic relationship between the words. And this is an advanced technique. Nowadays, almost all state of the model is using this kind of technique, that is word embedding. Now, as there are multiple methods available, how we can select which one is the best, right? So to select the best, we have to do few consideration. Okay, there are few consideration we should make. So what are those consideration? The first consideration is simplicity versus complexity. Simplicity versus complexity. Meaning, as a bag of word and TF-IDF are relatively simple, interpretable, okay, whether it is good or not for our current task, based on that we will use the bag of word. If your text is very small, your data is very small, not much more complex, it's easy to go ahead with the bag of word and the TF-IDF. Okay, but if you feel your data is very complex, okay, you wanted to understand the semantic meaning, and then semantic is play very important role, right? Then go ahead with the bag of word. And even if the data is huge, go ahead with the word embedding, not the bag of word. The second is the task specificity. Okay, what task you wanted to do. For example, if you wanted to do very simple task, right, then go ahead for the bag of word. But if your task is something related to the sentiment analysis, okay, let's say sentiment analysis or translation or translation, then use the which technique you are going to use, word embedding. Okay, so this is good technique to convert the text into the numbers, right? So these are the second criteria to choose the text representation. Now let's understand the one of the simple bag of word technique is called as a count vectorizer. Okay, so I'll explain you on the notebook also how this count vectorizer work, but this count vectorizer is available in the scikit-learn library of Python. Okay, so what it will do, it will convert the it will accept the sentence, convert into the number, and the matrix it will form that matrix in the ones and zeros. Okay, so let me uh, okay, so let me just go through the notebook, show you the notebook so that you will understand how it will work. So as you can see, one second. So as you can see on screen, this is a notebook I have created. So I'm using the sklearn library for the count vectorizer, and these are the sentence. So I have three sentence, right? We are learning NLP for everyone. Natural language processing is very interesting, and the natural language processing is evolve every day. Let's say I have these three sentence. I club into the list, then I'm initializing this vectorizer in the count vectorizer, and then I call the method called as fit transform, so that it will convert all these sentence into ones and zeros form. So when I call this method get feature names out, so what it is giving, it is giving me the what are the list of unique words available in this list. We can say R is the unique word, every day is something a unique word, evolving is the unique word, for is the unique word. So it is just consider the one instance of all the words, and then it takes the first sentence. Let's say I'm taking this first sentence, we are learning NLP for everyone. This is my list of unique word. So first I'll check whether the R is available in my first sentence. Yes, it is available. uh, R is available in the first sentence, so I mark this as a 1. Second, every day is appear in first sentence? No, then it is 0. Then everyone, is everyone appear in first sentence? Mark as a 1. Then third is the evolving, is available in first sentence? No, then 0. Then for, is for available? Then mark as the 1. Then interesting. So likewise it will, this is for first sentence. Wherever these words appear in the first sentence, mark that is 1, otherwise mark as a 0. Okay, so this way it will create the matrix for your sentences, and then these matrix are used for the training purpose. In the training, generally internally, the derivations, multiplications, all this mathematical operation is happening. Okay, so count vectorizer is a simplest form of bag of word. Okay, now let's go to the art notepad. Okay, I hope you understood how count vectorizer works. Now there are few limitations of this count vectorizer. What are those limitations? There are some limitations. Okay, so what are those limitations? The first limitation, it ignore the order. It ignore order and the semantics, right? It doesn't care. As you see in previous code, it doesn't care what is the order, what is the semantic. It ignore that completely, right? Third, once you use the count vectorizer, your vocabulary size is very huge. Okay, vocabulary size is very huge, and it is sometimes it is practically impossible to do this whole and huge size, and it will deteriorate your model performance. Third is that the, as you can see, this bag of word create this sparse matrix. Now what do you mean by sparse matrix? As you can see, this matrix has a more number of zeros than the 1. So if my matrix contains the more number of 0 than 1, then it is called as the sparse matrix, right? So it has a more sparse matrix, and definitely the computationally, as dimension increase, computationally is also huge. Next, with the bag of word, intrinsically it eliminating or reducing the significance of phrases that which are rarely occur. So it reduce the phrases, or I can say, or word that rarely occur. Understood? So it reduces the phrases or the words that rarely occur. Okay, this is the one of the, again, one of the disadvantage of the uh, uh, this is one of the disadvantage of this uh, yes, disadvantage of this count vectorizer. Now, though these are the some disadvantages, but what is the advantage of this then count vectorizer? Let's understand those. The first advantage of this count vectorizer, it is used for the some process called as a text classification, then sent document classification. Okay, so most of the classification things can be achieved in this count vectorizer. Okay, count vectorizer works best if you use some text pre-processing steps. Okay, if you don't, if you apply some text process like in our notebook, there are many stop words are available, right? There are many uh, small cases, means the case is a combination of lowercase and uppercase, right? Both. So if we apply some text processing before the count vectorizer, then this count vectorizer works best. This count vectorizer works best in the text pre-processing. Third, the if we apply this text processing, the another benefit, it reduce noise. It reduce the noise, and so once it reduce the noise, so your NLP model focus on focus on meaningful content. It focus on meaningful content. Okay, so this is the advantage of using the count vectorizer. Understood? Great. Now, once this, I hope I have practically shown you understood the count vectorizer. It means the bag of word very well. Now, let's again go back to the third, that is the TF-IDF. I already given the uh, meaning, but let's go deep into the TF-IDF. As I explained earlier, the meaning of TF-IDF is the term frequency inverse document frequency. When I say term frequency, means it calculate. So first let me uh, write down the formula so that it will easy to explain me further. So when you calculate the term frequency, means number of times the word, let's say that word is W, occur in document, occur in document. Okay, let's say in our previous example there is some word, right, which appear in all document. So you are first calculating the number of words appear in a document, then divided by total number of total number of words in document. So in short, you are just doing the calculating the frequency of that specific word. Let's say there is a word called V, it appears 100 times, and the number of words in the document is the, let's take one example. Okay, let's say there is a word called as V appear 100 times in the document, and number of total word is 1,000. Yeah, so let's say if there is a number of document appears is number of document in the is 1,000. So what will be the frequency? It will be the 0.1 frequency for that word called V. Okay, similarly, okay, similarly we can calculate the IDF. So how we can calculate the IDF? Okay, so IDF is calculating using formula called as log total number of document, total number of document divided by number of document, number of document containing containing word W. Okay, containing word W. So how many number of documents are available? If you divide that number of document containing word W, with this formula you can calculate the IDF. Let's say, for example, again the same example we take. Let's say I have 4 documents, right? And out of 4, only the 2 documents where that word is coming. So my IDF will become 2, right? So, and then you can calculate the weight. How you can calculate the weight here? You can calculate the weight TF into IDF, right? Now remember, this is a log. Okay, so TF is 0.1 into log of 2. So whatever answer, if you know the log of 2, whatever the answer will come, that weightage of that particular word. Okay, so we have taken the word called V, right? So that word, whatever the answer, that weight is assigned to that particular word. So this way this TF-IDF is calculated. So let me go to the notebook. I'll explain you how we can use the Python library to calculate this. Okay, so as you can see here, I'm using the scikit-learn feature extraction text library, right? Uh, of TF-IDF Vectorizer. Okay, and you just passing those sentence here and see. Similarly, we have these features. So fit transform will do the conversion, that what I have explained, that mathematical calculation happening here when you call this method. Then you are call out those feature names, and then you are converting that into the array. So these are the words are there, correct? These are the words are there. And if you can see now that once is replaced by with some 0.4, 0.4, with the point number. Wherever those words are not appearing, that is coming again 0. So it is again a sparse matrix, but it is not just one. Okay, it is the uh, using that formula, it calculating into this 0.4 or 0.1 whatever. Okay, so this way you can use the TF-IDF, right? I hope you understood. With the Python library, it is very easy to calculate the TF-IDF, but I hope you understand the mathematics behind that. Okay, let's go to the R. This way we can do this. So this way we can do this. Now let's go to the another thing, the some of the limitation. The same way we have listened some of the limitations of count vectorizer. So let's see what are the limitations of the TF-IDF vectorizer. Okay, limitations of TF-IDF vectorizer. So first is that computational is very expensive. The first foremost important is that it's a computation. As you can see, there are some operation, right, associated with TF-IDF. So computationally expensive, right? Second disadvantage is that, okay, so it does not take into account such as the co-occurrence of term or semantic or context associated with the terms. Okay, so it does not taking care context associated with words. Does not taking care the context associated with the words. This is the third problem, third limitation. Sorry, second limitation. And third, it depends on the vocabulary size, like count vectorizer. So this is also will get slow as the vocabulary size is increasing. So if you increase the vocabulary size, okay, so because it is similar to the count vectorizer, right? So this also slow, correct? Then TF vectorizer emphasize the words that are specific to the document, right? So, and it downplays the common words that appear everywhere. Okay, so as we can see when I was explaining, the words which are appearing distinctly gives the more weightage to that, but which are appearing frequently, it's lower down the weightage. Okay, again it is very helpful, like the disadvantage. uh, Similarly we have some advantage. Okay, so let's say what are the advantage. Okay, so there are some advantage associated with that. It is very good for the topic modeling. Okay, so I yesterday explained what is topic modeling, right? So those words, sorry, in my previous lecture, what is topic modeling, so which are so more effective, it creates the topic from that text very well. Also it is very good for the search engine kind of applications. So if you are doing something on search kind of application, this is very good. Even it also works very well for the summarization of the text application. Okay, so if your text if your data is very less, okay, so instead of using advanced technique, you can use TF-IDF for the summarization. So in that case also it works very well. After that, once this TF-IDF is done, I hope you understood, let's understand the n-gram. Okay, so what is n-gram? N-gram is something similar. Okay, something similar where you are just combining the words. So it let me just pull up this little bit. N-grams. So in n-grams, you are combining the consecutive words. Rather combine, combine consecutive words. So when you combine the consecutive words, so this helps to understand the relationship between the words. Why we are combining? Two, because in earlier count, vectorizer or TF-IDF, we are not able to understand the relation. But with this, we are able to understand the relation between words. This is the advantage of n-grams. Now there are different types. We will see in couple of minutes. So in n-gram, we have various type. Okay. So popular common n-gram is that unigram. Unigram means n is equal to 1. So when we say n is equal to 1, the meaning is that we are considering only one word. For example, that means the individual word. Okay, we are considering the individual word. Okay, for example, if I say the cat sat, okay, so the is different, cat is different, sat is different. The next is the bigram. When I say bigram, so n is equal to 2. So when I say n is equal to means what? So you are combining the two words together. So let's consider the example here. The cat sat. Okay, so before applying any bag of words or anything, in the unigram case, the all words treated separately. So the is different, cat is different, sat is different. In the bigram, when I say n is equal to, so I combine the two words. So first I'll take the cat, right? Then I'll take uh, the sat, right? After that I'll take the cat and sat. Okay. Uh, and the sat, the cat sat. Yes. This way we are taking the bigram. So bi means two. So when we are taking the trigram, okay, when we are taking the trigram, in the trigram, now your n is equal to 3. It means you are combining the three words. Similar the same example, let's how it works. Now I'm taking the cat, sat as the one word. Definitely, again you are reshuffling the order. So first the cat sat, okay, then you are taking the cat, sat, and the. Then you are taking the third shuffling sat, cat, the, right? So you are define the order, and this when I say n-gram, so it is not only uni, bi or tri. You can increase as number of number you want. So why we are doing this? Because of we wanted to understand to overcome the disadvantage or demerits of the count vectorizer. Okay, and this is what are the use cases. There are different use cases. The first use case I can see for this ngram is the language modeling. Language language modeling. So this is the first use case. Second is the machine translation. Third is the sentiment analysis, right? Then is the classification. So number of things we can do it. So let me share my screen and show you how ngrams work. Okay, through how we can do using the Python library. So if you can look at this, so we are using the count vectorizer, the same library, but we are just adding one parameter, that is analyzer is word. So we wanted to do the ngram based on the word. So there are different analyzer is available, and we are saying ngram is range 1 to 3, right? And then we are initializing the fit transform. So when I say 1 to 3 means is starting with the ngram, means we starting with the unigram, then bigram and the trigram. So all this combination we are including in the ngram. Now if you look at the same example that we take, it first take the individual words, then combine with the two words, and then it combine with the three words. Similarly, every day, everyone evolving similarly. So it is a combination of uni, bi, and trigram, and then this will form the matrix this way. So this way we also convert the advantage is that definitely it level up your semantic meaning, right? So this way we have completed this feature engineering. Definitely we will cover the advanced technology word embedding in another lecture, but the basic one I hope you understood very well. So we have covered the bag of word, count vectorizer, and the TF-IDF and the ngram. I'll share the link of this notebook on the description section of this video so that you can play with this on your own. Thank you for watching. Stay tuned.